Welcome back. I'm Dr. Chuck Kowaleski. I am an S3 controller and a mentor here at the VATSIM Jacksonville ARTAC. We're going to be doing the second of 3 classes on the S1 delivery ground rating. This is required classroom training for you before you move to Sweatbox to actually do practical training. You'll need this as well as the other two classroom training videos in order to proceed. And as I said on class training number 1, before you start a Sweatbox, there will be a knowledge check of these slides to allow you to continue on with Sweatbox. So please pay attention to this and the other 2 slide decks. And if you have any questions, you can certainly ask any of the mentors or instructors. There are also some embedded videos that I am not going to be playing, but they will be in the links in the description so that you can play them at your leisure. So let's get started. This is the Class 2 on weather. Pardon me. The content will be an introduction to the weather. We're going to look at METARs and how to read them, terminal aerodrome forecasts, and what the lowest usable flight level means. So the introduction. What is weather? Well, it's the state of the atmosphere at a place and time as regards to the heat, dryness, sunshine, wind, rain, all those sort of things. But in this case, with a definite attention paid to how it affects aviation. It's important because 1/4 of all aircraft accidents are actually related to the weather. And in the commercial world, 4 out of 10 times or 2 out of 5 times, the delays are due to weather, either en route or most commonly at the arrival airport, sometimes at the departing airport. That's particularly true in Orlando, where we see afternoon thunderstorms. And when there's lightning within a few miles of the field, the ground crews have to go inside, and that causes delays. So it changes day to day constantly within the National Airspace System. Most of the weather is provided by the National Weather Service, and that's transmitted to the controllers who interpret that for how they're going to operate the areas of their airspace. You can get that information on a regular basis. We'll talk about that. So the 2 types of weather reports are the meteorologic aerodrome reports, or METARs, pardon me, and the terminal aerodrome forecast, or TAFs. Let's first on the METARs. By having a standard format of METAR across the globe, it means that a METAR can be read no matter where you are flying to from anywhere in the world. It's corrected by the meteorologists, and it aggregates into this rather terse format so that it fits on screens and paperwork very easily, but it's also rather easy to read. The raw form is used worldwide, and it's standardized by the International Civil Aviation Association. So these are what METARs look like. We'll go over them in detail. You might want to come back to this part of the video and interpret them. And if you'd like a few minutes now, I'll pause just a few seconds so that you can pause the video and interpret these and see if you got them right. All right. What are the parts of the METAR? Station identification, the time of the observation, the wind, the visibility. We don't call it winds plural, we call it wind singular. Visibility, the sky conditions, temperature, dew point. Temperature and dew point is in Celsius, and the altimeter. In the United States, that is done in millimeters of mercury. In other parts of the country, it's in kilopascals. Interestingly, we use the term QNH for both, but QNH is typically what we call the altimeter setting, so you won't hear QNH too often in the United States. Let's break it down. So station identifier is your typical ICAO of the field. K indicates United States. There are actually about 9 different regions of K, but we just use the main K region, and then the 3-letter identifier. The time of the report is divided into the Zulu time, and therefore the Zulu day, and then whatever that time is in a 24-hour format. So this is the 13th day of this month, whatever that month is, at 11:53 in the morning, or 11:53 Zulu. and it has to be translated to local time. The wind is written with the direction in tens, so it's coming out of approximately 60 degrees. So 06, I'm sorry, written in digits. So it's sorry about that. It's so it's 060, and this goes obviously from 001 to 360. Interestingly, when the winds are calm, this will say all zeros. And then the next number of digits for the speed of the wind, and it tells you here that it's in knots. Uh, I've never seen 3 digits here. I don't know if it has that. Uh, so this is telling you the wind's out of the 060 or the northeast at 6 knots. The METAR only goes up to 10 statute miles, so this is always or greater. It'll show you the minimum visibility. It could be better. So this is 10 statute miles or greater. The or greater is implied. And then there's various levels here of few, scattered, broken, and overcast. And they're FEW, scattered SCT, broken is as a BKN, and overcast is OVC. So this is few at flight level 180. This one I got to write. This is in hundreds, so flight level 180. And then a scattered layer at 300. The temperature in Celsius is 18. The dew point is 14. And you can expect you will never see a temperature lower than a dew point because that's not possible. That's greater than 100% saturation. But when you see them meeting together or getting very close, you can expect it's very humid or there's precipitation. And then the altimeter in the United States is, as I said, it's given in millimeters, given in inches mercury, so it's 3016. And if you're flying the simulated aircraft, you know that you can switch it back and forth between the European and the American measurement. So decoding that one says is reported at Orlando International Airport on the 13th of the month at 11:53 Zulu. Winds reported bearing 0606, visibility 10 statute miles or greater. Cloud layers at flight level 180 and flight level 300. Temperature 18, dew point 14, altimeter 3016. Just as a point, we consider a ceiling to be anything that is broken or overcast. So there's no absolute ceiling in this METAR. If it had said broken 180, scattered flight level 300, we would have said the ceiling is at flight level 180. There are links for how to decode this. You can Google these. Frankly, it's so easy to read that I think you can pick it up. I've never used a decoder. It's fun to read the NOAA METAR abbreviations because there's all sorts of abbreviations you wouldn't have thought about lightning and precipitation, stuff like that. So it's worth looking at the METAR abbreviations. So can you decode this METAR? I'm going to have you pause here and work it out, and then we'll go back a little bit longer. If you can get through up to the remarks RMK, you're doing perfect. And for extra credit, if you can understand all this stuff down after the RMK, then you get extra credit points. So I'm going to pause. I'm not going to play this video because he does a very long explanation of the entire thing plus all of the automated weather, but we're going to go do this together and see if it's forward or backwards. There we go. All right, so this is Ann Arbor. That's what ARB is. On the 30th day of the month at 11:53 Zulu, the winds were essentially out of the north at 350. At 22 knots, the G means they're gusting to 31 knots. If you're a VFR pilot in the real world and you see this, your day of flying around the patch is probably over already because most small airplanes cannot handle either the gusts or the crosswind associated with that. However, you might be tempted because the visibility is 10 statute miles or greater. There is light rain at the airfield. There is a ceiling, because it's broken, at 1,700 feet. There's another broken layer at 2,500 feet, and an overcast layer or solid clouds at 3,900 feet. So the ceiling here is the lowest number, 1,700. But it's telling you that there's a lot of clouds overhead and they're fairly low to the field. I can tell you, having lived in Michigan, that most elevations are around 600 to 800 feet. So these ceilings, which are measured in with the mean sea level type measurement, not AGL, that you're looking at a broken layer that's right at the altitude you'd fly for flying patterns. So it'd be very questionable if you'd be flying VFR and BS as a student pilot today. The temperature is 2 centigrade. The M indicates it's minus, so it's a minus 0.1. So it's a chilly day. It's about 30, 31 degrees Fahrenheit. The altimeter is 2.9 or 4.8. And then remarks is a separator for whatever comes afterwards. In this case, it's telling you there's an automated observation system, type 2, which is the most common type. And that automated observation system recorded a peak wind coming out of 330 at 35 knots, and that was at 11:42 Zulu. That probably is the most important thing in a remark you'd want to know about, right? The rest of this stuff you really don't need to know, and we don't use it in VATSIM, so I'm not going to waste your time with it. If you really want to learn about it, this video will tell you all about those abbreviations and what they mean. So the Terminal Area Forecast, or TAFs. This is a format to show predicted or possible weather in the future. They're issued regularly every 6 hours, and they usually apply to 24 to 30 hours ahead of time. They don't come out exactly on 0 or 06 or 12 or 18. They come out close to it. And they involve they will give you the weather close to the field, like within 5 miles radius of the field. The military issues them every 3 hours, and it varies at civil airfields, and they can go up to 30 hours, from 3 to 30 hours. Why so far in the future? Well, because people fly across the pond and they really need to know the weather forecast that far in advance. So these are typically used with the METAR to get an idea of what the forecaster has done, and they're produced by humans. They're not done by any machines. They're usually done by a local meteorologist in the National Weather Service, so they will also be accurate, taking into account the local weather conditions, whether there's geographic effects, a whole line of buildings along one side of the airport that affects the weather, that sort of thing. So here's a sample TAF, and we'll go over it, but I'm going to wait a few seconds here and give you an opportunity to pause the video and see if you can read the whole thing on your own. Okay, so let's go over the parts of the TAF, and then we'll go back and look at it. Again, has a station. It's very similar format to the METAR. It makes it easy to understand. Station identification, the block of time for that prediction, the predicted wind, predicted visibility. Again, that's still the minimum or better, and the predicted sky conditions. Now, that should appear several times in several lines, and we'll talk about how they do the times. So when you decode it, the first line is going to say from, so this will be the 15th day of the month, from 0 Zulu. That we predict the winds will be out of the southeast 110 at 6. And we predict that it'll be 6 statute miles visibility or better. And I don't know why we put predict there and not everywhere else, but we don't. And the sky conditions looks like we will have a few clouds at layers 3,000, 6,000, and flight level 250. So let's go back here for a little bit and look at this one. That's what this said. But I want to point out the first line was rendered at the 14th day at 1742 Zulu, and it's valid for this time period, from the 14th day at 1800 to the 15th day at 2400. These are not Zulu times. These are telling you the day that it's valid for and the time it's valid for. So from the range of 1800 Zulu on the 14th to 2400 Zulu on the 15th, these lines will be valid. Again, so initially it will be starting at the 14th day at 1800. It'll be 110 at 10 knots. Predicted 6 statute miles, scattered 4,500, broken 6,000. And then that region of period ends at the 15th day at 000 Zulu, and that one we just read. And then that region ends at 1500 Zulu on the 15th day, and now we have 1606, predicted 6 miles, scattered 4,000, scattered 3, flight level 300. And then that ends at 1800 Zulu on the 15th day, where this one begins, and it is coming out of the south at 9 knots, predicted 6 miles, scattered 6,000, scattered 3,000. So if you were in Orlando and you saw this and you knew you were flying in and you were going to get in around sometime on the 15th at 1500 Zulu to 1800 Zulu, you could predict, since the winds are out of the south, that Orlando is going to be landing to the south. So that helps you with your flight planning to look at the TAF, because it gives you a pretty good idea of which direction the airfield is going to be when you get there. Now, last thing is the lowest usable flight level, and this is particularly useful to know in Florida where we see hurricanes, because hurricanes have very low altimeter settings, and we'll go into that. So by definition, the definition in the flight regulations for aviation in the VFR flight regulations is 91.121, what we call the FAR. Each person operating an aircraft shall maintain the cruising altitude or flight level of that aircraft, as the case may be, by reference to an altimeter that is set ... The part that matters to us is the lowest usable flight level is determined by the atmospheric pressure in that area of operation. So the lowest altitude in which an IFR aircraft can cruise above flight level 180 may be determined by the local atmospheric pressure. Let's go into that a little bit thinking about it. Before we go into the table, if we think of air as a volume, and we think of low pressure as air being low density, the altimeter is looking at how much air as a volume is below me. So we know if the density is lower, there's less air below me. So to get my altimeter to read the same altitude at a low pressure, I've got to be higher so that I get more air below me. In contrast, if it's a really cold day, like minus 20 centigrade, and we got a really great high going on of 311 something, 3110 say, that means that the high pressure means I've packed the air in and it's cold. So to get the same amount of volume of air, it's all been squished down into this dense air mass. I don't have to fly as high in the airplane to get my altimeter to read the same altitude. By setting the altimeter to whatever it is for the airfield, we compensate for that. But when we get to flight level 180, which defines which airspace? Quick think in your head. Did you say Class A? Good. That's an IFR airspace in Class A. If the altimeter setting is very low and I need more air to get my altimeter to show a flight level of 180, that means I'm actually higher than flight level 180 to get that reading. And it gets to the point where to get higher, I'm actually encroaching on the 29902 value that we use for standard pressure above flight level 180, the so-called transition altitude. So people flying on a VFR flight with an altimeter very low, below 29.92, may actually be as high as the IFR folks flying on the standard temperature pressure of 29902 at flight level 190. And we got to keep aircraft separation in that space. So the way we do it is we cut off where the Class A airspace begins. And we do that through this table. So, and we get this in hurricanes in Florida. This absolutely happens around us. Temperatures get very low. And when they do, the person has to be, a VFR pilot could potentially be flying above flight level 180. Therefore, the folks flying IFR or using a transition altitude have to know that that the transition altitude is still 180, but they cannot fly below a certain flight level. So during a hurricane, if the altimeter is 2945 over here, let's say, did I say that right? No, I'm sorry. Let's change that. Let's say make it between there, 29er, 2899er. Let's put it there. So somewhere in the middle. It's in this range. Then we cannot give someone a flight level below 190 if they're going to be using 2992 as their standard because they're above 180. So the way we compensate is people who are going to go use a transition altitude setting when we have low pressure below that transition altitude simply aren't given a clearance below one of these altitudes. And that guarantees that the folks who think they're at below flight level 180 but they're on a really low altimeter setting gives them the vertical distance space between those flying above the transition who are on 2992, and we just make sure they're at flight level 190 or above, and that way we're ensuring that we have vertical separation between those people below the transition level and those above the transition level. Hopefully I didn't confuse you too much on that, but if I did, just remember that you're not going to clear people for altitudes below one of these flight levels if the altimeter setting is in one of these ranges. And you can copy this, snapshot it, and keep it as an image as a reminder if you like. And that's it. We have done class 2 for student number 1. Again, if you the embedded video will be a link in the description that you can play back at your leisure. And remember, if you have any questions, contact an instructor or a mentor, and we'll try to help you through that. Otherwise, good luck in your sweatbox training. Look forward to seeing you.